Now let's just start with the very first topic, which is nothing but called as the mean of the grouped data. So first of all, we know that how we can find the mean of the ungrouped data. So we know that the mean of the observations is actually nothing but is equal to sum of the observations divided by the total number of the observations. We all are already aware about this particular formula. Now let us suppose if I'm just extending this formula for the frequencies as nothing but, let us suppose we are just taking x1, x2, x3, so goes on xn are the observations with the respective frequencies that are f1, f2, f3, f4, fn and so goes on. Then the mean is actually represented by x bar. Mean is represented by x bar. As you can see over here, the mean is represented by x bar, which should be nothing but is equal to f1 x1 plus f2 x2 plus f3 x3 so goes on plus fn xn divided by f1 plus f2 plus f3 and so goes on plus fn, which is nothing but is equal to this symbol. This symbol is actually nothing but a Greek symbol which is called as a sigma. It is nothing but a sigma which actually represents a sum. So here you can see we are just taking the product of the observations with respect to their frequencies. So this is actually representing sigma fi xi, which is nothing but the sum of all the frequencies with the multiplication of their respective observation divided by sigma fi. This is nothing but a Greek symbol again, and we call it as nothing but sigma. So this symbol is representing a sigma. So this is a sigma fi, and fi means the sum of all the frequencies that we have. So now the formula that we are getting for the mean of the grouped data as nothing but x bar is equal to f1 x1 plus f2 x2 plus f3 x3 so goes on fn xn divided by f1 plus f2 plus f3 plus so goes on fn, which we can also represent with the help of a Greek symbol which is called as a sigma. So this is nothing but sigma fi xi divided by sigma of fi, where sigma is actually denoting a sum of the frequencies with the respective observation. So as you can see over here, this sigma fi is actually nothing but representing whole this numerator, and this sigma fi is actually representing whole this denominator. So you can represent this particular form into this particular form as well with the help of a very special symbol which is nothing but a sigma. This is called as a sigma. So now remember the formula for the mean when we have the observation with the respective frequencies as x bar is equal to sigma fi xi divided by sigma fi, where x bar denotes the mean. X bar denotes the mean. So mean is nothing but is equal to sigma fi xi divided by sigma fi, where sigma fi xi means the product and the sum of the respective frequencies with their observation divided by the sum of all the frequencies, that is sigma fi. Now let's just talk about some of the methods through which we can able to find out the mean. So in order to find the mean of a grouped data, we are using three terms, or we can say that we are using three concepts. The very first is nothing but called as a direct method through which we can able to find out the mean of a group data, and the second method is called as the assumed mean method through which we can also find the mean of the group data. Moreover, the third type of a method is called as the step deviation method. So in this chapter we will discuss about all these three methods to find the mean of the grouped data. So let's just start with the very first method, which is nothing but called as the direct method. So let us suppose if I'm just starting with the very first concept of finding out the mean of the grouped data, which is nothing but called as the direct method. So how we can find the mean in the direct method. So first of all, let us suppose I am just talking about a particular concept that for each class intervals, we all are aware about the class intervals, we require a point to serve as the representative of a whole class. So definitely for each class intervals, we definitely require a particular point that exists as a representative of the whole class, and in this we know that midpoint is chosen as a representative. Midpoint is always chosen as a representative because it is definitely assumed that the frequency of each class interval should center around its midpoint, and we all are aware about that how we can find out the midpoint of the intervals. So the midpoint is also called as nothing but the class mark. So if we just wanted to find out the midpoint, so the midpoint or class mark is one of the same thing. It is nothing but is equal to upper class limit plus lower class limit divided by 2. So in the direct method, this particular formula would help us a lot to find out the mean of the grouped data. So always remember, in the direct method we will find the class mark, which is also called as the midpoint, which exists as a representative of the class. And how we can find the midpoint or the class mark? Class mark we can find out with the help of the formula, which is nothing but the upper class limit plus the lower class limit of the class interval divided by 2. So remember this particular formula, which is nothing but called as the class mark. Now let's just see an example which is related with the direct method, that what is actually called as the direct method of finding out the mean of the group data. So let us suppose if I'm just taking an example, and we have the marks which are obtained by 30 students of class 10th of a certain school in mathematics paper consisting of 100 marks are represented in the table. So let us suppose this is my table and we have to find the mean. So we are here finding out the mean using the direct method. So what is the direct method? Let's just see. Let us suppose if these are the class intervals, as you can see these class intervals are continuous. We have 10 to 25, then 25 to 40, then 40 to 55, 55 to 70, and so goes on. And we have the number of the students, means the frequencies. These are actually representing the frequencies, which is nothing but 2, 3, 7, 6, 6 and 6. So let's just convert it into a table. So first of all, when I'm just starting the mean or starting the process of finding out the mean of this particular data, first of all I'll write the class interval and the number of the students. So let us suppose if I'm just forming a table for this one for the direct method. So let us suppose if this is nothing but the table. So first of all, let's just look only at the two tables. Forget about these two. So we only have these two tables. So this was the given question, the class intervals and the number of the students. Number of the students were actually representing the frequencies, which is nothing but represented as Fi over here. This is nothing but represented as Fi. So always remember, whenever we have the other table which is along with the table of the class interval, so that would be a table of the frequency. So this was given to us in the question, that is the class interval and the number of the students, which is actually represented by the frequency, that is nothing but Fi. Now let's just to find out the midpoint, which was actually existed as a representative of the class interval. So we know that how we can find out the class mark. Class mark are always represented by Xi. Always remember this fact. Class marks are represented by Xi. And we know that how we can find out the class mark. So let us suppose if I'm just talking about the very first class, which is 10 to 25. So I'm just finding out the class mark for this particular class. So we know that the class mark is actually nothing but is equal to the upper limit plus the lower limit divided by 2. So let us suppose if I'm just talking about the very first class, so you can see we have the lower limit as 10, the upper limit as 25 divided by 2. So this is nothing but 35 by 2, and 35 by 2 is definitely nothing but 17.5. So you can see over here, for the class interval 10 to 25, the class mark is nothing but 17.5. So using this particular formula, I have calculated all the class marks. So you can see for the next one, we have the class interval as 25 to 40. Now let's just find out the class mark for this one. So let us suppose if I'm just writing it over here, the class mark for the second should be nothing but is equal to upper limit plus lower limit divided by 2. So as you can see, this is nothing but this is 25 is nothing but my lower limit. This is nothing but my lower limit. I hope you already know about this fact. This is my lower limit, and 40 is nothing but called as my upper limit. This is nothing but my upper limit. This is nothing but my upper limit. So this is nothing but lower limit is 25, upper limit is 40 divided by 2. So this is nothing but 65 by 2. So this is nothing but 2 into 3 is 6, 2 into 2 is 4, 0.2 into 5 is 10. So we have 32.5. You can see all by yourself that this is nothing but 32.5. And in the same way, I can calculate the class mark for 40 to 55. This is 47.5, 55 to 70, this is 62.5, 70 to 85, this is 77.5, and 85 to 100 is nothing but 92.5. So this is nothing but all about the class marks. Always remember the class marks are represented by xi, small of xi, small of xi. We always represent the class mark as small of xi. So since this is nothing but my first class mark, so this is represented as x1. This is my second class mark, so this is represented by x2, and so goes on. So this is my x1, this is my x2, this is nothing but x3, this is nothing but x4, this is nothing but x5, and so goes on. So now in the direct method, first of all, we will find the sum of the frequency. The sum of the frequency means the sum of all these. So 2 plus 3 plus 7 plus 6 plus 6 plus 6. It is actually nothing but is equal to 30. And this symbol is again, let us suppose if I'll recall the symbol, this is a Greek symbol which is nothing but called as the sigma, which actually represents the sum of all the terms that should be given over here. So sigma fi means we are taking the sum of all these frequencies, that is nothing but f1 plus f2 plus f3 plus f4 plus f5 and plus of f6. So we are taking the sum of all these, which is nothing but sigma fi, which is equal to 30. Now in the last table, we will find out the product of the class marks with respect to their frequencies, because we know that if we just wanted to find out the mean, so the formula for the mean is nothing but x bar, which is nothing but is equal to f1 x1 plus f2 x2 plus so goes on plus fn xn, which is whole divided by f1 plus f2 plus so goes on plus fn. We already know about this formula. We already have learned about this formula, that for the observation x1, x2, so goes on xn with their respective frequencies f1, f2, f3, so goes on fn, the x bar represents the mean, which is nothing but is equal to summation of or sigma of fi xi divided by sigma of fi. So this is nothing but the sigma symbol, which is representing the sum of all the frequencies and sum of the product of the frequency with respect to their observation. So using this formula, I am actually calculating this particular table. So you can see over here, for the very first we have fi xi, means we have to multiply the frequency with their class mark. So let's just multiply the frequency with the class mark. So we have 2 into 17.5. So 2 into 17.5 is nothing but is equal to 35. You can calculate it all by yourself. And for the second we have 3 into 32.5. 3 into 32.5, which is nothing but 97.5. And further we have the respective frequency with their class mark, which is nothing but 7 into 47.5. So this is nothing but 332.5. So we are getting further 6 into 62.5, which is nothing but 375.0. And further we have 6 into 77.5. It is nothing but is equal to 465.0. And further we have 6 into 92.5, which is nothing but is equal to 5555.0. And after taking the sum of all these, we are getting the sigma fi xi as nothing but is equal to 180 1860.0. So this is nothing but the sum of all the sum of the product of the frequencies with respect to their observation. Now let's just calculate x bar. So we know that the value of the sigma fi xi is 1860 and the sum of the fi is nothing but 30. So let's just take the division of 1860 with respect to 30. So we are getting x bar is equal to sigma of fi xi divided by sigma fi, which is 1860 by 30, and after calculating it we are getting the answer as nothing but is equal to 62. So at the end we are getting the mean of this particular grouped data as nothing but 62, which is nothing but representing my mean, which is representing the mean of the data that we have. So this whole method is nothing but called as a direct method. This method is called as a direct method. So always remember, whenever we are just applying the direct method to find out the mean of the grouped data, then first of all we have to find out the class mark, which represent xi, which is nothing but the sum of the upper class limit plus lower class limit divided by 2, and then we have to form a table in which we have to multiply the observations with respect to their frequencies, and then we have to take the sum of all these and we have to divide them with the sum of all the frequencies, and then we will able to get the answer of the mean of the data. So this is all about the direct method.